Good morning. Welcome to the lecture session on Bilinear Transformation 1. In today's lecture, we are going to discuss about the introduction about the bilinear transformation. The bilinear transformation is a transformation of the form W is equal to AZ plus B by CZ plus D, where A, B, C, D are constants and AD minus BC is not equals to 0 is called bilinear transformation. If a point Z maps onto itself under the bilinear transformation, then the point is called an invariant point or fixed point of the bilinear transformation, that is W is equal to Z. Cross ratio. If Z1, Z2, Z3 and Z4 are four distinct points, then the ratio Z1 minus Z2 into Z3 minus Z4 divided by Z1 minus Z4 into Z3 minus Z2 is called cross ratio of the point, denoted by the 4 points Z1, Z2, Z3 and Z4. The working rule is as below. Usually 3 points, that is Z1, Z2, Z3 will be given onto W1, W2 and W3. In the second step, we have to substitute the given set of points in the formula W minus W1 into W2 minus W3 by W1 minus W2 into W3 minus W. So Z is Z minus Z1 into Z2 minus Z3, Z1 minus Z2 into Z3 minus Z. This is the formula in which you need to substitute the values of Z and W. Now, we need to solve the equation for W in terms of Z. Fourth step is W is equal to AZ plus B divided by CZ plus D is the required bilinear transformation that transforms from Z1, Z2, Z3 onto W1, W2 and W3. That means we will be getting the equations, 4 equations with 4 variables, that is A, B, C, D, which can be solved. Then we will get the values of A, B and C, D, which is substituted in the W equals to AZ plus B by CZ plus D. There we get the required bilinear transformation. Example, find the bilinear transformation that maps the points 1, 0, minus 1 onto the points I, 0, minus I. Solution. We know that 3 points, that is Z1, Z2, Z3 maps onto W1, W2, W3. Given 1, 0, minus 1 onto I, 0, minus I, which implies we respectively name them as Z1 as 1, Z2 as 0, Z3 as minus 1 and W1 as I, W2 as 0, W3 as minus I. So we have the formula W minus W1 into W2 minus W3. Z minus is equal divided by W1 minus W2 into W3 minus W. Same way, right hand side z minus z1 into z2 minus z3 divided by z1 minus z2 divided into z3 minus z. This is the formula, and we have the values for z1, z2, z3 and w1, w2, w3. We will substitute in the formula. Thereby we are getting w minus I into 0 plus I divided by I minus 0 and minus I minus w is equal to z minus 1 into 0 plus 1 divided by 1 minus 0 into minus 1 minus z. So this we have replaced with respectively the w values and then the z values. And in the left hand side we can take the I common in the numerator as well in the denominator, apart from the minus sign in the denominator. And in the right hand side we can get z minus 1 divided by minus taking common 1 plus z. On multiplication of I to the left hand side we get wi plus 1, because I into minus I will become I square with a minus sign, that will become plus. And in the denominator minus I into plus I will be minus I square, which will become plus, and it will be wi minus 1, and minus can be taken to the left hand side or multiplied on both the sides, so that we have in the second step we have here z minus 1 by minus of I1 minus z. So in the next step this minus gets eliminated, so we get wi minus 1 in the left hand side is equals to z plus 1, that is in the denominator. Next, cross multiplication gives us wi plus 1 into z plus 1 is equal to wi minus 1 into z plus 1. Thus implies on multiplication wi plus wi plus z plus 1 is equal to wi minus z minus wi plus 1. That is on multiplication we get it. And by taking the common terms to the left hand side, that is I terms to the left hand side and non-imaginary, that is the real parts to the right hand side, we get z into wi minus z into wi plus wi is equals to minus z plus 1 minus 1. Plus 1 and minus 1 cancels in the right hand side. Z into wi and minus z into wi gets cancelled in the left hand side. So we get 2wi is equals to minus of 2z. Cancelling 2 on either side, we get wi is equals to minus z, or w is equals to minus z by I. But we know that 1 upon I is minus of I. Therefore, we get the bilinear transformation as w is equals to zi, which is the required bilinear transformation. Thank you. You can get back with the doubts.